The Robotic Industries Association wishes to thank the following member companies for their support, which made the production of this video possible. Though each is individually different, all robot systems share one common characteristic. Each can be a potential hazard for the personnel who operate, teach, or maintain it. Robots usually improve safety in the manufacturing environment because they remove humans from the need to perform dangerous tasks under hazardous conditions. However, robots can still cause serious injury if the personnel are improperly guarded or otherwise unaware of the potential hazards. The Robotic Industries Association, a leader in robot safety for over 25 years, has updated the American National Standard for the safe use of industrial robots and robot systems. This 1999 standard provides guidelines for the manufacture, remanufacture, installation, and safeguarding of industrial robots. Because every robot system is different, the standard should be used as the foundation for developing a specific safety training program suited individually to each robot application. The 1999 standard is divided into 14 sections. The scope, purpose, applications, and exclusions of the standard. Normative references. Definitions. Manufacture, remanufacture, and rebuild of robots. Performance requirements of safeguarding devices. Installation of robots and robot systems. Introduction to safeguarding of personnel. The prescribed method of safeguarding personnel. The risk assessment method of safeguarding personnel. The implementation of safeguarding personnel. Safeguarding devices. Maintenance of robots and robot systems. Testing of robots and robot systems, and safety training of personnel. Additionally, there are 5 informative annexes to help understanding the standard. This video presents an overview of those sections of the standard that specifically address the safeguarding of personnel. After viewing the program, the entire standard should be reviewed for more detailed information on robot safety. Every robot system is different in terms of size, speed of motion, and payload capacity. The following 3 examples illustrate some of the important ways that robots vary from one another. In our first example, the robot system performs a material handling function for an induction hardening process in the manufacture of front-wheel drive axles. The robots are mounted in an overhead or gantry position. The end effectors, the tools used by the robot to perform its task, are in this case grippers. Other end effectors might be suction cups, paint spray apparatus, loading electrodes, or metal cutting devices. In our second example, the robot is in a robotic tray handling system used by the United States Postal Service. In our final example, the robot system performs a general spot welding function for automotive body assembly. The cell is comprised of multiple robots, some pedestal mounted, some floor mounted. The robots use spot welding guns as end effectors. Another important difference between robot systems is the displacement at which the robot can move, as demonstrated in this animation. A robot's joints, such as its elbow and wrist, allow it to be flexible and move through large areas of space, both vertically and horizontally. When fully extended, this robot can move in an almost complete circle. The total space within which the robot can move is called its maximum space, shown here in tan. If a limiting device has been installed, the robot's movement for a particular application may be restricted to a smaller area, called the restricted space, shown here in blue. A limiting device restricts the robot's maximum space by stopping all robot motion independently of the control and application programs. Restricted space may change if the robot is installed in a different application and with different limiting devices. The robot performs its function within an even smaller space, called the operating space, shown here in purple. Again, the operating space can change if the robot is reprogrammed to perform a different task. Application, configuration, and space are just some of the ways in which robot systems can differ. Every system can be different, and every difference presents a new set of potential hazards for the personnel who work with it. Anyone manufacturing or remanufacturing a robot is required to uphold the safety of the future personnel who will be working on their robot. Of primary importance is to install control reliable safety circuitry so that any single component failure shall not prevent the stopping action of the robot. The pendant or teaching control device shall have an enhanced enabling device using a 3-position switch, which when continuously held in a detented position permits motion. Releasing or fully depressing the switch shall immediately stop the robot motion. Other important information about the manufacture, remanufacture, and rebuild of robots can be found in Section 4 of the Robot Safety Standard. A robot can carry heavy weights, move quickly over large distances, or use sharp or otherwise dangerous end effectors when performing a task. Personnel in the robot's environment can be at risk of injury if safety practices or procedures are not utilized. To maximize personnel safety in a robot environment, users must ensure that the system be installed in accordance with the installation guidelines presented in Section 6 of the Robot Safety Standard. The installation guidelines cover installation specifications, environmental conditions, location of robot controls, safety-related software, use of limiting devices, proper grounding, power disconnect, stopping circuits, equipment shutdown, and other important considerations. Refer to Section 6 of the Robot Safety Standard for more detailed information on robot installation. Personnel safety continues after robot installation by selecting a safeguarding method. The required safeguards per Section 8 are installed in accordance with Section 10. Or, per Section 9, a comprehensive risk assessment conducted to define appropriate safeguards and installed in accordance with Section 10. The prescribed safeguarding of personnel requires devices to prevent access to or stop the hazards without a deliberate action by the affected personnel. Prescribed safeguards are either mechanical devices or operating procedures used while the robot is in operation. The restricted space shall be established by installing limiting devices. Implementing safeguards requires safety circuitry limiting robot motion through mechanical limiting devices, like this hard stop shown here. There may also be non-mechanical limiting devices like this electromechanical limit switch, or others such as relays or blocking valves. Electrically integrated dynamic limiting devices may also be utilized, such as light curtains or control-activated retractable hard stops. Protection of personnel outside the restricted space shall be ensured by perimeter guarding, which establishes the safeguarded space by preventing access by interlock barriers and/or presence-sensing safeguarding devices. Here, an arc welding robot behind flash curtains is fed by a turntable. This system features prescribed safeguard devices, including presence-sensing devices and barriers. There are several different presence-sensing devices, including light curtains and safety match systems. A presence-sensing device stops the motion of a robot if personnel enter the work cell. The motion cannot be restarted without deliberate activation. Barriers ensure that personnel cannot circumvent the device and reach the hazard without being detected. In this application, a high fence serves as a barrier. Barriers must cover an area between 12 inches and 60 inches off the floor as a minimum. Barriers shall contain hazards like loose parts, which would become projectiles. Flash curtains can also contain hazards, but mainly serve to protect the personnel's vision from the arc welding process. An interlock barrier, such as this interlocked access gate, allows access to the robot when necessary. If open, the robot's motion stops and cannot be restarted without deliberate activation. Like all robots, this system also includes awareness lights that